So much of what we do in math and much of what is done in life is relationships or relations, usually between two sets of information, right? So it could be like one set of information is time, and other set of information is distance traveled, or something like that. Um, One set of information is uh, words, and the other set of information is whether how many times the letter A is in those words. I mean, there's all sorts of relationships that you can describe. Okay, so mathematically, when we talk about relationships or relations, okay, we talk about a set. We use the word set. And set just refers to a collection of information. Now, when you think of math, usually a set contains numbers. But it doesn't have to. It could contain words. It could contain just letters. We're eventually going to focus on numbers, but when we start this, we're going to talk about numbers and letters and words. Okay? The element of a set, the word element, means one piece of information from that set. So like if we had a set of numbers 1 to 10, an element would be 5. Or an element would be 7. If I had a set of information that contains all the letters in the English alphabet, a set of that information would be Q, and so forth. Okay? A relation is some rule, and it could be mathematical or it could be just sort of described in English, that associates one set of information with another. Somehow they're connected. And we're going to see a bunch of examples of that in this lesson as we go along. And again, could be numbers, like the two pieces of the two sets of information could be numbers. One could be numbers, the other could be words. One could be letters, the other could be numbers. Who knows? Okay. So here's an example of one. Two sets of information. We've got one set that contains the letters A, B, C, and D. So how many elements are in that set? 4. And we've got another set that contains 3 words: act, cod, and tab. How many elements are in that set? 3. Right? So right now, we haven't talked about how they're related to each other. Okay? As soon as we talk about how they're related to each other, then we've formed a relation. Okay? So the rule is, from the first set, no, I don't think I actually described it, the actual relationship. Would be, okay, the relationship would be the letters in this set and the words that they appear in this set. Okay? So there's a bunch of different ways we can write it. One is ordered pairs. So we're going to break down each one in the entire relation. And here's what we do. We put a brace to start, and then we put all the potential components of that relation in the braces inside parentheses. So let's take the letter A. A appears in what word or words? Right. So one part of the relation is A act. The second one is A tab. And then we just keep going. B appears in just tab. C appears in act and cod. And D appears in just cod. Okay? So these are all the components of the relationship. If we define the relationship as the elements in the first set that appear in elements of the second set. So letters that appear in words. Okay? So that's one way to show it. Notice we haven't used any numbers yet in this first example. Another way to show it, table. In a table, you list all the pairs in parentheses, except you list them down. So A, act, A, tab, B, tab, C, act, C, cod, and D, cod. It's another way you can show a relation. A graph. Okay. It would probably be hard to graph this. Okay. But we could do it. We will be doing graphs, more graphs with numbers. Okay. Another way that you haven't seen before is something called an arrow diagram. And an arrow diagram looks like this. Draw two ovals. First oval contains all the elements in the first set. So A, B, C, D. The second oval contains all the elements in the second set, the three words, act, cod, and tab. Now I want to show all these, okay? Because remember, like there's basically six components in this relation that we've established. We did 6 ordered pairs. We did 6 rows in a table. I've got to do 6 here as well. What we do here is we do arrows. So A appears in act, so I draw an arrow from A to act. I also draw another arrow from A to tab because it appears in 2 elements in the second set. So I'm going to have 6 arrows. B appears in tab. C appears in act and cod. And D appears in cod. So it can get a little messy. But notice we've got 6 arrows to represent the 6 components in the relation. Okay. The order that you do all these in matters. Okay. It all depends on how the relation is described. I described it as letters in the first set and the words they appear in the second set. If I decided to reverse it, I would say the words in the first set that contain the letters in the second set. The order that you describe it matters, because then you'd have to reverse everything. Right. Let's look at a few examples. Mostly words, some numbers. Okay. But really, all I want you to do with this lesson is be familiar with some of the terms I used at the beginning and different ways we can show a relation. So here we have a relation that's shown in a table. Okay. And what's the relation? Northern communities here and the territories that they belong to. That's the rule. So that's the relation. So we want to do it as a set of ordered pairs. Well, all you have to do from the table is take each one and put it in a set of parentheses with braces at the front and back. So we'll just do a little bit of shorthand to save ourselves some writing. So Hay River in the Northwest Territories is one component of this relation. Second one is Iqaluit, which is in, and I'll just do NUN for short, Nunavut. Nanisivik, Nanisivik, is also in Nunavut. Old Crow is in the Yukon. Whitehorse is in the Yukon. And Yellowknife is in the Northwest Territories. Okay. Parentheses are important, so are the braces at the front and back. I'm running out of space here, so I'm going to put it over here. Arrow diagram. Well, the territories, there's 3 of them. So in the second set, Northwest Territories, Nunavut, and the Yukon. In the first set of information, there's 6 different communities. And I'm just going to go, so I don't have much space. Hay River, IQ for Iqaluit, NAN for Nanisivik, OC for Old Crow, Whitehorse, and Yellowknife. I'll just put white and yellow. And then we just connect the ones that relate to each other. So Hay River, Northwest Territories. Iqaluit is in Nunavut. Nanisivik is also in Nunavut. Old Crow is in Yukon, as is Whitehorse. And Yellowknife is in the Northwest Territories. Okay. So there, you should be able to convert from one form of a relation to another. Right now, we've focused on ordered pairs, tables, and arrow diagrams, but they can also be graphs, as we see in the second example. What's the relation? The dog breed is associated with their mean heights. You know what that means? There's another word for that you know. Average. In statistics, we use the word mean to describe average. So, dog breeds, 6 dog breeds associated with their average heights. And we want to do it as a table. So we're given as a graph. We want to convert it to a table, and we want to then convert it to an arrow diagram. So we've got to be able to read the graph. So as a table, well, we can, let's just put AH for the Afghan, CHI for the Chihuahua, or otherwise known as Chihuahua, Corgi, Golden Retriever, GR, German Shepherd, GS, and a Malamute. Ooh, big dog. Big husky looking dog. So, what's the average height of, or the mean height of an Afghan? 75. Okay, and we'll label this too. We'll put breed. Mean height. Chihuahua? 20. And I should put centimeters here too, so I don't have to keep writing centimeters every time. Corgi? Yeah. Golden Retriever? 60, as is the German Shepherd, and the Malamute? 65. Okay, so that's pretty straightforward. And then as an arrow diagram, again, 2 ovals. Put the 6 dog breeds and how they appear on the graph. Corgi, Golden Retriever, German Shepherd, and the Malamute. Can't believe they don't have a lab in there. And then just list the numbers, 75, 20, 30. Tell me something. Do you have to do 60 twice? No. You just got to draw 2 arrows to it. So don't, yeah. If an element appears more than once, you don't have to write it twice in an arrow diagram. So, like so, like so, like so, and then we've got 2 arrows going to the 60, and like so. Okay. Finally, and this is always one I find interesting, because it tests your geography skills. First of all, the relationship in words, it's Western Canadian cities that are within 1 hour driving of another Western Canadian city. Okay, so we won't worry about writing all that out. But I am interested in B. Can you give me an ordered pair that satisfies this? A Western Canadian city, so you need a city, comma, that's within 1 hour drive of another city. Yes. Winnipeg and Port La Prairie. Winnipeg and Gimli. That's pushing an hour, isn't it? But I'll go with what you guys say. We could have done a closer city than Gimli up north, maybe Selkirk. Why are you looking at me like that? More. That's pretty good. You know what? You guys have actually been the best at this in all the years I've done this example. Because I think in previous years, a class has only managed to give me one. Right? Regina and Moose Jaw. They're pretty close together. Kind of like Winnipeg and you could have done Winnipeg and Steinbach. That's another one. Okay. So that's all I want to introduce you to today, is just what these relations are, how we can show them. So for Thursday's class, I would like you to do